After we can define the type of our singular point, then in order to find the solution of x0, which is a regular singular point, it says that we can assume that y is equal to summation of an times x minus x0 to the power of n plus r. N is equal to 0 to infinity, and r is a constant. And this solution would be in the range of the absolutes of x minus x0 to less than rho. Rho is the radius of convergence. Okay? And in order to find the solution, we are going to use the Frobenius method. The Frobenius method saying that we've got to find the r value, and the r value is finding from the initial equation, which is defined as r times r minus 1 plus p0r plus q0 equal to 0, where p0 and q0 you finding it from the limits of x minus x0 px, where x approaching x0, and for the q0 is equal to limits of x minus x0 square times qx, where x approaching to x0. So from this, it is the r square equation. So you can find two values of r. Okay, and two values of r is saying that we are going to take the big number to be r1 and the small number to be r2. And from that r, we r1 greater than r2, okay, we can divide the way to find the solution into three cases, which are: case 1, if r1 minus r2 is not an integer, it means it's a fraction. If it is not an integer, you would get two independent solutions, which is a1 is equal to summation of an times x minus x0 to the power n plus r1, where a0 is not equal to 0 and the summation starting from n equal to 0 to infinity. And the second solution, y2 is equal to summation of bn x minus x0 to the power of n plus r2, where b0 is not equal to 0 and also the summation starting from n equal to 0 to infinity. And the case 2, if r1 equal to r2, you would get two independent solution, which is y1 is equal to summation of an times x minus x0 to the power of n plus r1, where n starting from 0 until infinity. And for the second solution, you would get that it's equal to y1, which is this one, times ln x minus x0 plus summation of n starting from 1 to infinity of bn times x minus x0 to the power of n plus r1. This is because this case both r1 and r2 are equal, so we would find the term of n x minus x0 to the power of n plus r1 the same for these two terms, but only the coefficients in front of it are different. And case 3, where r1 and minus r2 is an integer, is a positive integer. It's got to be positive integer because R1 is greater than R2, right? You can't get negative integer because if R1 is bigger than R2, then you would get positive integer only, right? Then the solution would be y1 is equal to this term and y2 is equal to this term, where c is a constant and sometimes c can be 0. It is up to the condition that you consider. Okay, and you know that the r value is from initial equation. If you don't remember this equation, when you derive the equation itself, it will lead you to the initial equation. So you can find the value of r by using this equation, or you can derive from your equation, you will get the same. Okay. Now let's take a look at the example. Let me keep this one. This one is in the textbook already, so you can find the information from the textbook. Okay. Let's take a look at the first example. It says that find the value of x0. Find the value of this differential equation around x0 equal to 0. From this, we got to find whether this x0 is ordinary or singular point. So from that, we got to starting from px and qx. Consider the point which is the ordinary or singular. So from this, we would get px is equal to 6 over 4x and qx is equal to minus over 4x. From this, x equal to 0 is a singular point, right? Because at x equal to 0, qx and px is the non-analytical function. So the rest of x would be ordinary point. Now, because we know that they are asking us to find the solution at x equal to 0, and now we know that x equal to 0 is a singular point. So we got to prove that x equal to 0 is a regular or irregular singular point. If it is regular, then we can use Frobenius method to find the solution. Now, in order to find whether x equal to 0 is regular or irregular, we use these two criteria: x minus x0 px and x minus x0 square qx. Now our x0 is equal to 0, so we get x px, which is x times 6 divided by 4x, so we got 6 over 4, which is the number. And for the qx, we would get x squared qx, which is equal to minus x over 4. So for both functions at x equal to 0, make these two functions to be an analytical function. So that means x0 is a regular singular point. Now, we can find the solution by using Frobenius. So that means the assumption of this the assumption of the solution of this differential equation is y equal to summation of an times x minus x0 to the power of n plus r, where n starting from 0 to infinity. So you can start in finding r from initial equation that is given to you, which is r times r minus 1 times p0, r plus q0 equal to 0. And then find p0. P0 is equal to limits of x px, where x getting approaching 0. So from this, it's equal to 6 over 4 or 3 over 2. And your q0 is equal to 0. So you plug the value of P0 and Q0 into your initial equation. This equation called initial equation, right? You plug the value in there. We got this initial equation. You can find the value of R from that. Okay, so we've got 2R squared plus R equal to 0. So we got two value of R, which is 0 and minus 1 over 2. So which one is R1? Which one is R2? Which one is R1 and which one is R2? It says that R1 always bigger than R2 or greater than R2. So which one is R1? You got two numbers, 0 and minus 1 over 2. Which value has a higher value? 0. So R1 is 0 and R2 is minus 1 over 2. Then we are going to find the value of R1 minus R2. R1 minus R2 equal to 1 over 2. 1 over 2, which is in case 1, which is R1 minus R2 is not an integer, right? 1 over 2 is it an integer? Integer in Thai we call จำนวนเต็ม เต็มไหมเนี่ย ไม่เต็ม First case saying that R1 minus 2 is not an integer. So that means with this example, with this problem statement, it fits to case 1. And case 1, you know that you have two solutions of y1 and y2. y1 is summation of a1 times x minus x0 to the power of n plus r1. And y2 is the summation of bn times x minus x0 to the power of n plus r2. So we got the first solution and second solution. Now R1 is equal to 0, so you got an x to the power n. R2 equal to minus 1 over 2, so we got bn times x to the power of n minus 1 over 2. So our final solution would be y equal to c1 y1 plus c2 y2. Right? No yp, right? Because if you take a look at your differential equation, it's a second order homogeneous differential equation, so you got no yp, right? And it is having variable coefficient, right? Because we have x instead of the constant. Now, you know that your y1, but the thing is that you don't know your an. You got to find the recurrent relation in order to get an. And for y2, you also need to find the recurrent relation for bn. In that case, you can find the final solution of your y. So the way that they do is just that beginning from derive starting from assume that y is equal to an x to the power of n plus r. x0 is equal to 0. We are writing in the general form first, and then after we got recurrent relation, we plug the value of r in. right? Where r is equal to 0 and r is equal to minus 1 over 2, something like that, okay? Then you plug the value, you plug the y into your differential equation. So you have to do derivative of y 2 times, right? The first derivative you would get an times n plus r times x to the power of n plus r minus 1. And for the second derivative, you would get an times n plus r times n plus r minus 1 times x to the power of n plus r minus 2. And then you plug all three terms here into your differential equation. You would get 4x times the second derivative of y, which is this, plus 6 times the first derivative of y, which is this, and minus y equal to 0. And then you try to rearrange and combine each term in order to get the Lagrange relation. So you have x here, you combine this x with this x. So you would get x plus to the power of n plus r minus 1, right? Your x here, you put it inside there, you would get x to the power n plus r minus 2 plus 1. Minus 2 plus 1 equal to minus 1 there. Now, as you can see, these two terms look pretty much the same, right? Because you have x to the same power. So you combine these two terms together, you would get 4an times n plus r times n plus r minus 1 plus 6an times n plus r. And then you put the parentheses there and times with x to the power of n plus r minus 1 minus the summation of an times x to the power of n plus r equal to 0. Now, we are going to consider whether we should make, because we want to combine all these terms together. So we should make x to the power n plus r minus 1 become n plus r, or we should make n plus r become n plus r minus 1. Yeah, we got to make it to be n plus r minus 1. In that case, we got to replace this term with n minus 1. Okay. So we replace the second term with n minus 1. So we would get summation of n minus 1 equal to 0 to infinity. And this an would be an minus 1. And now your x would become to the x to the power of n plus r minus 1 equal to 0. Now, your n become n minus 1. So which is n equal to 1. N minus 1 equal to 0, so n is equal to 1. So that means this term n starting from 1 to infinity. So these two terms still cannot combine together unless you make this term starting from 1. So in that case, you've got to plug the value of 1 in there, and the rest of the term will be the summation of x starting from 1 to infinity. So when I plug n is equal to 0 in there, I would get a0 r, right? Because n equal to 0, 0 plus r is equal to r. And here, n is equal to 0, you got r minus 1. And there, we would get plus 6a0 times r. And the whole term times x to the power of r minus 1. Right? And the rest of the term, you can put it as the summation of this term. Still be this term, but it's starting from n equal to 0 to infinity. Now, this term and this term, you can combine them together because you have the same power of x, and the summation starting from the same point, which is n equal to 0. N is starting from 1 to infinity. So the next step is just that combine the terms together. So we will get this.